A supervolcano, an extremely brief reversal of the geomagnetic field, and climate variability by Helmholtz Associated German Research Centers. 41,000 years ago, a complete and rapid reversal of the geomagnetic field occurred. 41,000 years ago, magnetic studies of the GFZ German Research Center for Geosciences on sediment cores from the Black Sea show that during this period, during the last ice age, a compass at the Black Sea would have pointed to the south instead of the north. 41,000 years ago. Moreover, data obtained by the research team formed around GFZ researchers Dr. Norbert Nowazek and Professor Heltz Ars, together with additional data from other studies in the North Atlantic, the South Pacific, and even Hawaii, prove that this polarity reversal was in fact a global event. Their results are published in the latest issue, Scientific Journal Earth and Planetary Science Letters. What's remarkable is the speed of the reversal. The field geometry of reversal polarity, with field lines pointing into the opposite direction when compared to today's configuration, lasted for only about 440 years, and it was associated with a field strength that was only 1/4 of today's field, explains Norbert Nowazek. He says the actual polarity changes lasted only 250 years. In terms of geologic timescales, that is very fast. During this period, the field was even weaker, with only 5% of today's field strength. As a consequence, the Earth nearly completely lost its protection shield against hard cosmic rays, leading to significantly increased radiation exposure. This is documented by peaks of radioactive beryllium, 10 Be, in ice cores from this time recovered from the Greenland ice sheet. 10 Be, as well as radioactive carbon 14C, is caused by the collision of high-energy protons from space with atoms of our Earth's atmosphere. I support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. So Earth only had 5% of its magnetosphere. The Lechamp event, the polarity reversal now found in the magnetism of Black Sea sediments, has already been known for 45 years. It was first discovered after the analysis of the magnetization of several lava flows near the village of Lechamp near Clermont-Ferrand in the Massif Central, which differed significantly from today's direction of the geomagnetic field. Since then, this geomagnetic feature is known as the Lechamp event. However, the data of the Massif Central represents only some point regarding readings of the geomagnetic field during the last ice age, whereas the new data from the Black Sea give a complete image of geomagnetic field variability at a high temporal resolution. Now, abrupt volcanic climate changes and supervolcano. Besides giving evidence for a geomagnetic field reversal 41,000 years ago, the geoscientists from Potsdam discovered numerous abrupt climate changes during the last ice age in the analyzed cores of the Black Sea, as it was already known from the Greenland ice cores. This ultimately allowed a high-precision synchronization of the two data records from the Black Sea and Greenland, the largest volcanic eruption on the northern hemisphere in the past 100,000 years, namely in the eruption of the supervolcano 93,400 years ago in the area of today's Phlegrean Fields near Naples in Italy. It's also documented within the studied sediments from the Black Sea. The ashes of this eruption, during which about 350 cubic kilometers of rock and lava were ejected, were distributed over the entire eastern Mediterranean and up to central Russia. So from Italy, it went all the way up to central Russia. These three extreme scenarios, a short and fast reversal of the Earth's magnetic field, short-term climate variability of the last ice age, and the volcanic eruption in Italy have been investigated for the first time in a single geological archive and placed in precise chronological order. This is by the Helmholtz Association of German Research Centers on phys.org. But we have another evidence of a second fast north-south pole flip found as well. The Earth's magnetic poles flipped around every 200,000 years or so, with north becoming south and vice versa. Normally, the process takes 4,000 to 5,000 years, and it ought to be impossible for the flip to be much faster if models of the Earth's core are correct. But now, for the second time, evidence has been found of a flip that happened. It took only a few years. The first evidence was discovered of a rapid geomagnetic field reversal was in 1995, when well-preserved lava flows were found at Steens Mountain in Oregon in the United States. Research on the rocks by a team led by geologist Scott Bogue and the Occidental College in Los Angeles revealed the lava flow had an unusual magnetic pattern that suggested the magnetic field had been shifting over 10,000 times faster than normal at 6 degrees every single day. It was shifting at 6 degrees every single day. The magnetic patterns are preserved within the magnetic crystals in the lava formed as the lava flow cooled. The first findings remained controversial, and many scientists have challenged the fast flip-flop theory, but now Bogue and colleagues Jonathan Glenn of the U.S. Geological Survey have found evidence in ancient lava rock in Battle Mountain, Nevada, of a second fast flip. It was dated around 15 million years ago. Now that was when we have the beginning of the Snake River Plain that ended up in today's Yellowstone supervolcano. Now the record in one particular lava flow in Nevada suggests the magnetic field moved 53 degrees in a single year. The lava started to cool, but was then heated again within a year as it was buried under fresh lava. The crystals in the rock were remagnetized by the fresh lava, producing a shift of 53 degrees, and this finding could mean the poles swapped over a period of only 4 years. 4 years! But Bogue said it could also suggest there was a rapid acceleration period within the steady movement of the field. According to some geologists, a polarity reversal is overdue since the Earth's magnetic field has been weakening for the last century. And the last stable reversal was about 780,000 years ago. Even if it was a super fast flip-flop, though, it would not be noticeable to most people. No one is certain why such reversals take place, although many scientists believe they are connected in some way with the convective movements of the liquid iron in the Earth's outer core. This was from phys.org, magnetic field reversals, Bogue, very rapid geomagnetic fields, geophysical research letters. Please leave your comments, and thank you for your support. So, based on the studies of old volcanic basalt, scientists know the Earth's magnetic field reverses at irregular intervals ranging from tens of thousands to millions of years. Volcanic basalt rocks containing magnetite. When the rocks cool, the magnetic properties are frozen, locked into the Earth's rocks and Earth's magnetic field of the time. And with this data, scientists estimate that the last magnetic field reversal occurred about 780,000 years ago. Although volcanic basalts revealed when reversals occur, it's much more difficult to find evidence for why or how the Earth's magnetic field reverses. In recent studies, scientists from École Normale Supérieure of France have proposed a general mechanism providing a simple explanation for field reversals. In their model, small fluctuations in convection flow in Earth's core can push the planet's sensitive magnetic system away from one pole towards an intermediate state where the system becomes attracted to the opposite pole. They said we found a mechanism which gives simple explanations of many features of the reversals of Earth's magnetic field. In particular, it explains the existence of the shape slow phase followed by fast phase of reversals, the existence and the shape of aborted reversals or excursions, that's a little bit of a shift, the statistical properties of reversals, and the possibility for very long durations without reversals or supercrons. Right now, the Earth's magnetic field can be described as a magnetic dipole, with the magnetic south pole currently located near the Earth's geophysical north pole, and the magnetic north pole near the geographic south pole. Both magnetic poles are misaligned along the Earth's rotational axis by about 11.3 degrees. The existence of such a long-lived magnetic field can be explained by dynamo theory. It describes how a convective, electrically conductive fluid rotating can maintain a magnetic field. I'll leave links below for you for this. Please leave your comments, and thank you for your support.